Ever get that feeling like when you see all this buzz around LLMs, these large language models, you think to yourself, okay, there's got to be more to it than just these super powerful computers, right?
Yeah.
Like it can't just be about throwing more GPUs at the problem. That's kind of what we're going to deep dive into today,
Yeah.
unpack what's really going on under the hood with these language-based AI systems.
Yeah, absolutely. There's this tendency to focus on the impressive things LLMs can do, and it makes it seem like the more powerful the computer, the better the AI. But
Sure.
it's more nuanced than that. There's a whole interplay of factors at work here.
And to guide us through this, we're tapping into the insights of Saad Sheikh, who's like a really respected figure in the field. His article on Medium, Improving AI Models' Trust Through Deep Language Understanding, really breaks things down in a way that's super helpful. He goes through the evolution of NLP, natural language processing, and points out the really essential pieces that make modern LLMs tick.
Right, and Sheikh's not just like some random commentator. His work has been deeply involved in AI and how it connects to language.
Exactly. So it's not just about the what of LLMs, but the how and why. So our mission today is to understand, beyond the obvious computing power, why LLMs really depend on these other things:
hmm
data, statistical models, and this deep understanding of language. And we'll be using Sheikh's article as a roadmap.
Makes sense. And I think Sheikh starts off by laying some important groundwork, really. He
Right.
highlights how fundamental language is, not just for communication, but for like the whole of human intelligence and how we've built our societies.
Right. He makes that point that it's not just about talking to each other. It's like language is built into how we think and how we make progress as a species. If
hmm
you think about it, from ancient cave paintings to the internet, it's all about language, sharing ideas, passing on knowledge, building on what came before. It's all rooted in language.
And he even uses this really powerful statement like, even God used language to communicate to his people. It shows how deeply we perceive language as a force.
Yeah, it's not just a tool. It's almost like this foundational element of our existence.
And that's where the connection to AI comes in. If AI's goal is to reach some level of human-like intelligence, its ability to interact with us meaningfully depends on understanding and using language. That's the bridge, right?
Totally. And to see how we got to where we are with AI and language, Sheikh gives us this really neat overview of NLP's history. He breaks it down into these distinct periods. The first one, from the 50s to the late 60s, he calls simple rule-based translation. It was like the first baby steps. Just imagine, those early attempts at machine translation were probably pretty clunky compared to what we have now.
Oh, for sure. Back then, it was all about trying to define super specific rules for how words and grammar translate between languages, like a machine trying to use a grammar textbook to understand human speech.
You can imagine how quickly they ran into limitations with that approach. Human language just has way too many nuances and exceptions.
Exactly. So then things shifted in the next era, from the 70s to the early 90s. She calls this period language maths. The focus became understanding the deeper structure of sentences, the syntax, and also the meaning behind the words, the semantics. He talks about this program called SHRDLU. Why was that so important?
I was wondering about that. What made it stand out?
Well, SHRDLU was a program that demonstrated a pretty impressive level of language comprehension, even if it was within this very controlled environment. Like they had this virtual world made of blocks, and SHRDLU could understand instructions like move the red block on top of the blue block, or answer questions about the arrangement of the blocks. It showed that applying computational techniques to syntax and semantics could get you closer to more meaningful communication, even if it wasn't something you could apply broadly just yet.
So even though it was limited, it kind of showed the potential of using computational methods to really grasp language, right?
Right, and you could say that this era really started exploring those statistical patterns within language, even if they weren't explicitly calling it that at the time.
Okay, that makes sense. Then we move into the third era, which Sheikh labels algorithms, from the mid-90s to around 2012. He points to the growth of computing power and the development of more sophisticated algorithms as the key factors here. It sounds like this is where things started to become more practical, more applicable.
Definitely. This is when NLP started to move towards empirical methods. Instead of just relying on these carefully handcrafted rules, Researchers started training algorithms on massive data sets, allowing them to learn patterns from real-world language use. This led to a lot of progress in things like classifying text, analyzing sentiment, and retrieving information.
The kind of things that underpin a lot of the technologies we use every day, right?
Exactly. Those algorithms were becoming much better at recognizing the statistical relationships within language, understanding the patterns that emerge when you analyze huge amounts of data.
And then we land in the fourth and current era, deep learning, kicking off around 2013. This is when neural networks and deep learning methods really started to dominate. Sheik talks about how we started representing words and sentences as these things called embeddings and vectors. It sounds pretty technical. What does that actually mean for AI's ability to deal with language?
Well, it's like this. Imagine you have a map, right? And each word has a specific location on that map based on its meaning. The closer two words are on that map, the more similar their meanings are. That's kind of what embeddings and vectors do. They represent words in this multidimensional space, capturing not just the word itself, but also its relationship to other words.
So it's not just about knowing happy is a word, it's about understanding that it's closer in meaning to joyful than to sad.
Exactly. And this ability to grasp semantic similarity was a huge leap forward. It meant that AI could start to understand the nuances of language in a way that was never possible before. Plus, being able to process larger chunks of text as a whole was a major game changer.
And Sheikh specifically points to 2017 as a pivotal year with the rise of supervised fine-tuning, or SFT, on these massive data sets. He mentions Google Search and AWS e-commerce as examples where this was super effective. And this is also when AI scaling laws became a hot topic, right? This idea that you can keep improving AI just by feeding it more data, more compute power.
Right. Supervised fine-tuning was like taking these models that had already learned a ton from this huge amount of general text data and then fine-tuning them on smaller task-specific data sets so you could get really good performance on a specific task. And the scaling laws suggested that you could just keep making things better by scaling up the amount of data, the size of the models, and the compute power.
But then Sheikh brings up another important innovation, the transformer architecture and those attention mechanisms. Remember that famous line from the paper, attention is all you need. So how did this architecture really change the game for NLP?
The transformer, especially with this attention mechanism, allowed these models to do something really clever. They could weigh the importance of different words in a sentence when processing language. So instead of just going through a sentence word by word, it could look at the whole thing and understand how different words relate to each other, even if they're far apart. It's like when you read a paragraph, your brain naturally focuses on the key words to understand the overall meaning. That's what attention mechanisms enable AI to do with language.
So it's not just about recognizing individual words, but understanding how they all fit together to convey meaning.
Exactly. And this was key to the huge jump in performance we've seen in LLMs. They're able to understand context, the relationships between words, and that's a game changer for tasks like translation, question answering, and generating text that actually makes sense.
Okay, so we've gone from basic rules to statistical models and then this deep learning revolution with transformers and attention. But Sheikh then brings up a point that I think gets overlooked sometimes. He talks about the critical role of data. And not just having all the data, but having the right kind of data, high quality data. He even uses this term scarcity when talking about good data samples and raises a really important question about whether just scaling up with more data is actually sustainable in the long run.
It's like you can have a huge haystack, but if you're looking for a needle and most of the hay is just like useless stuff, it doesn't really matter how big the haystack is, right?
Exactly. And what's really fascinating to me is that looking back on the history of NLP that Sheikh lays out, it becomes clear that statistical models have been at the heart of this evolution all along. From those early attempts to codify language patterns to the complex neural networks we have today, it's all about identifying and understanding those statistical patterns in language. We talked about the language maths era earlier. Well, you could say that that was really a turning point where they started to use mathematical and statistical methods to understand how language is structured and what it means. Instead of just trying to write down all the rules, they started looking for those underlying patterns in how people actually use language.
Yeah, that's a great point. Even the early rule-based systems were, in a way, trying to capture those regularities, but in a very limited and explicit way. As NLP moved towards machine learning and deep learning, the models became much better at picking up on those complex statistical relationships in the data. At the end of the day, these LLMs, they're essentially statistical models that have been trained on huge amounts of text to predict the next word in a sequence. Their ability to generate text that sounds coherent and relevant, it all comes from those statistical patterns they've learned from the data.
And this brings us back to the title of Sheikh's article, right? Improving Trust in AI Models Through Deep Language Understanding. It's not enough to just process words at a surface level. It's about getting to a real understanding of the nuances of language. He
Hmm.
even points out that we don't fully know how much these models actually know, which is kind of a mind-blowing thought. And this raises all sorts of questions about trust and potential biases, especially since they're learning from all this data out there on the internet, which can be pretty messy and biased itself.
Absolutely. Deep language understanding means going beyond just recognizing words and their grammatical structure. It means getting the context, the relationships between concepts, and even the subtle things that are implied but not directly stated. While LLMs have come a long way, their understanding is still based on the patterns they find in the data. So if that data reflects biases or inaccuracies that exist in the world, those can end up getting baked into the model, sometimes without us even realizing it. And sometimes the way these deep learning models work, it's hard to understand exactly how they're representing knowledge or making decisions, which makes it even harder to address those potential biases.
And Sheikh then brings up these two strategies, supervised fine-tuning, or SFT, and retrieval augmented generation, RA, to show that just having these massive pre-trained models isn't always enough for real-world tasks. He explains how SFT involves taking a pre-trained model and then fine-tuning it on a specific data set for a specific task. So you can get really good performance on that particular task, but it can be expensive and computationally intensive. Plus, there's always the risk of overfitting, where the model gets so specialized that it loses some of its general abilities.
Right. And then there's Arvity, where the model can actually access external knowledge bases to get more information before generating a response. This is really useful for tasks where you need access to up-to-date information or information that wasn't included in the initial training data, like question answering systems or research assistants. But it also has its own challenges, like making sure the retrieved information is actually relevant and accurate, and dealing with the time it takes to retrieve that information.
So both SFT and RGRE kind of show that even with these huge pre-trained models that have learned so much, you often need to do more. You need to add more data, more mechanisms to make sure they're giving you accurate and relevant information for a specific task. It's not just about the initial training, it's about continually refining and grounding their understanding.
Yeah, you could see these deployment methods as ways to bridge that gap between the vast general knowledge of LLMs and the more specific real-time demands of different applications. They're practical solutions that address the fact that no model, no matter how big or powerful, can know everything or have access to the absolute latest information.
And finally, Sheep talks about his vision for the future, which centers on these ideas of human-in-the-loop AI, or HITL AI, and human reinforcement learning feedback, or HRLF. His point is that even with all the amazing progress we've made, AI can't replace human judgment. We need to involve human expertise to guide, validate, and correct these systems, both during training and when they're actually being used.
That's a crucial insight, I think. It's acknowledging that true understanding, like what we humans do, goes beyond just processing information. It involves judgment, context, common sense, all those things that AI is still figuring out.
So wrapping it all up, Sheik's insights make it really clear that LLMs are way more than just powerful computers crunching numbers. They depend on these massive data sets, the sophisticated statistical models that can learn from that data, and this ongoing effort to improve how they understand the nuances and complexities of human language. The history of NLP really highlights how these different factors have come together to get us where we are today.
Exactly. The things that make LLMs so impressive, they come from this convergence of factors. Compute power is just one part of the equation. The data they're trained on shapes their understanding, the statistical models allow them to extract patterns from that data, and all these research advancements in things like attention mechanisms and those deployment strategies like RRIG, they're all about making these models better at truly understanding and generating language.
And it's fascinating to see how the role of humans, as she points out, is still so crucial. We need to be involved to guide these systems, to make sure they're aligned with our values and goals, and to ensure that they're used in a way that benefits society.
Definitely. It's a reminder that as powerful as these technologies are, they're still tools, and it's up to us to use them responsibly and ethically.
So here's a final thought for our listeners. As these LLMs become more and more integrated into our lives, how do we make sure that this deep language understanding they have is actually robust and trustworthy, especially when you consider how complex language is and how these models rely on these vast, sometimes messy data sets. It's a question that goes beyond the technical aspects and gets to the heart of how we build these language-based AI systems in a way that benefits everyone.
It's a great question and one that we'll need to keep exploring as this technology continues to evolve.
Thanks for joining us on this deep dive. Until next time.